Hello everyone. In this video, I'll discuss about the schedule and different types of the schedule. Schedule is a execution sequence of transactions. Here we have a T1, T2, T3 and up to Tn. Number of transactions are coming for the execution and each transaction will be performing the number of operations. So these operations, how they will be performing in sequence, that it is called as a schedule here. Transaction manager will be giving a guidance about scheduling, how to prepare the queue among all these transactions, and scheduler will prepare the schedule. That scheduler is a software which it will be preparing the queue of these competing transactions. According to the schedule prepared by the scheduler, that the execution of the transaction takes place. This entire process, it is called as a schedule. Schedule, it will be containing number of transactions and each transaction will be containing a number of operations. Schedules can be classified basically into two types, serial and non-serial. So serial schedule, one after the other it is. Non-serial, it is a concurrent execution. As it is a concurrent execution, it will be having a number of problems here. Here we have a further many precautions will be taken for the scheduling. But whereas when it is a serial schedule, here there is no any problem related to the execution. Always the schedule will be giving the consistent output and there is no intervention of the one transaction within another. That's what it will be clear. The execution always it will be accurate here. Whereas a non-serial schedule, it is a concurrent execution. Multiple transactions, they will be performing the task by interleaving one in another. That's what here we have a interleaved operation. It is intervention of the one transaction, it will be taking to other. So further classification, here we have a serial schedule that it is one after the other, like this one of the transaction after completion of that only next one. Otherwise, here we have a T1, T2, T3, T4, any of the transaction, it may start with the execution after completion of that only next again further it will be taking. So always it will give a confirmation about these properties. That is a serial schedule. It is a consistent, recoverable, cascadeless, and strict. Always it will be following these properties. So there is no any confusion regarding the serial schedule. Always it is accurate. Non-serial schedule. Non-serial means here we have a intervention of any other transaction when one of the transaction it will be executing. So here we have a read, T1 it is started execution, reading A, writing B, and before completion of the T1 operation only, again T2 it will starts. Like that only before completion of T2 it may go for another. Here we have a that again it will switching to the previous one. So by switching from one transaction to another transaction, the entire task it will be completed. So this it is called as a non-serial. So non-serial, it may or may not consistent, recoverable, cascadeless, and strict. So further here we have a checking whether it is a consistent or non-consistent or whether it is a recoverable. We have a different types of the schedules here. So here we have a difference between the serial as well as non-serial. Diagrammatically, it will be representing after completion. Here T1 it will be committed and then it will goes to T2. It will starts and it will be committing. Then it will goes to T3 and all. But here we have a interlude execution it will takes. Then here we have a serializability. Serializability means now this is the serial schedule and this is the non-serial schedule. Suppose this non-serial schedule, it is giving the output as a serial schedule. Serial schedule always it will be giving the consistent output. Like that even non-serial schedule also it may go for the accurate output. So when it is giving the accurate output like a serial, then this schedule it is called as a serializable. Even though it is a non-serial, but it is a serializable, means we can convert it into the serial schedule here. So this it is called as the serializability. Difference between the serial and serializability. Serial, after completion of the one transaction only, next one. There is no any interlude operation. But non-serial, that serializability, it is basically non-serial, but it is giving the consistent result as a serial. Means we are able to convert this non-serial to serial form. that it is called as a serializable. Then next here we have a conflict serializability. So here confliction between the different operations. When we are saying the conflicted, here we have a three basic features are required. Conflicting operations are required in the schedule. One is the schedule with a multiple transactions. And when multiple transactions are there, and here we have a same data, it will be shared among the multiple transactions. So even though same data it will be sharing among the multiple transactions, any one of the operations should be right. When all the three property, any one of these three properties it will be affected, then it is called as a conflict serializability. So here we have a conflict pairs. When we are saying the confliction, that is the conflict serializability means. So here we have a schedule with a multiple transaction, and these transactions are shared with the same data, and any one of the transaction it will be having the right operation. In this you can notice now one of the schedule it is taken, that is a non-serial, in which we have a two transactions T1 and T2, and the same data it will be sharing among both, that is read A and write A, write A. Any one of the transaction it will be having the right or both. So now both the side we have a right here. Then definitely it will goes for the confliction. This it is called as a conflict. Means here maybe read write or write read. Means any one of the transaction it is having the right operation on the same data, then it will be of the conflict serializable. Then now here we have a how to check this conflict serializability, whether it is conflict serializable or non-conflict. In order to check whether the schedule it is a conflict serializable, we are using the precedence graph. So graph how it is created means with respect to the read-write confliction it will be created here. So now here we have a T1, T2, T3, three transactions we have taken. Now T1 it will be reading data item A. So that A, anywhere it will be writing in other transactions, just we have to check. Here again it is a read. In between read and read, there is no any confliction at all. So T1 is not having any confliction with the T2 as well as T3 with respect to this operation. Then we have to come to the next one, read B. Now here it is a read B. In T2, anywhere it is a write B, and again in T1 it is a write B. It is not there. Again here it is a read. In between read and read, there is no any confliction. Then T3 with respect to this operation, it is not having any confliction here. Then it will comes to read A. So read A, and this read A, here there is no any write A at all. But here in T1, it is having the write A operation. Means it will be writing. Now T3 to T1, it is having the confliction. So here we have a T3 to T1. The direction we are showing. Now we have a three transactions T1, T2, T3, and now from T3 to T1 it is having the confliction, means we have to show the arrow like this. Then we have to come to the next operation, that is the RB, read B. Read B, here we have a T3, it will be writing the B. So read B as well as write B. T2 to T3 it is having the confliction. So T2 to T3 we are showing the direction here. And like that only, now here we have to come for the read C. Read C, anywhere there is a write C. Read C, it is having the write C for the T1, T2 to T1. Already it is taken T2 to T1. This direction we have to show here. And like that only, here we have a write B. Write B, and here we have a write A. That already T3 to T1 it is taken here. And then we have to go for the write C. Write C, here also it is a write C. T2 to T1 also it is taken. Then no more further comparison here. RC, WA and WC are not further compared with any of the transactions. So now here there is no cycle formation. If we notice this one, there is no cycle formation. Then we'll say it is a conflict serializable. This schedule, it is a conflict serializable. If it is having the cycle like this, anywhere it will be showing the cycle formation in the graph, then it is called as a not conflict serializable. So in this way, we are finding whether the schedule it is a conflict serializable or it is a non-conflict serializable. So this is one method. One more method, we can go for the swapping between a non-conflicted operations. In conflicted operations, we are not taking the swapping here. Here we have a swapping. We can interchange the position of the read as well as transactions, that is read operation as well as write operation. So here we have a swapping operation. How it will take means, in this example, we have a two transactions. It is given that read A, write A, and read B. And after that, we have a read A and write A. This is a serial schedule, and this one it is a schedule S dash. This is S and this is a S dash. Means this one we have to convert into this format because it is a serial. After completion of the T1, it is started with a T2. So here we have a T1 and T2, they are having the interlude operations. Now we have to check whether it is a serializable or non-serializable. So in this, we have a conflict equivalent serializability we are going to check. Then here we have to compare that read B as well as write A. That read B, write A. That A, B, we have a two separate data items. Then there is no confliction. In order to get that confliction, we have a two transactions, same data item, and one of the operation it will be right. But data item it is the different. Anyone it is false means no confliction at all. So now we have to go for the swapping. That just I'll be placing this RB to the upper position and WB that it will be taken to the lower position. Like that, here we have a RB as well as RE. That A and B, two different data, and it is a read operation. So we can shift it. Now by converting it into the, by swapping the non-conflicted operations, now it is converted into the serial schedule. This is one more method to check whether it is a serializable or non-serializable. So in this way, either we have to use the precedence graph or we can go for the swapping. So here we have a view serializability. Then why we have to go for the view serializability? So view serializability in case of the serializable and non-serializable, when there is a cycle formation, that it is called as a non-serializable. So non-serializable, sometimes it will give a consistent output and many times it will be giving the inconsistent also. So still it is unpredictable whether it is giving the accurate output or inaccurate. To check that one, we have to go for the view serializability. We have to proceed with the view serializability here. And in view serializability, we have a different rules are there, conditions. That first, when we are saying that two schedules are the view serializable means, here we have a certain conditions. The initial reader should be similar. Means here we have a first read operation. It should initial read of the two schedules should be same here. And final write should be same for two schedules. And update read, it is same for two schedules. Now we have a two schedules, S1 and S2. Here we can go for the identity. In this, we have a S1 as well as S2. These two schedules we are seeing, these are the view serializable. When we are saying view serializable means first read operation where it is taken in the S1, it is in the T1 transaction. Like that in S2 also it is required in the T1. First read operation, it is in the T1 only. Then next we have a update read. Update read means that after by writing one of the transaction, it is reading means that is called as a update read. Now update read, it is taken in the transaction T2. So here we have a update read, it is taken in the transaction T2 itself. It is same. And again here we have a final write. Final write, it will be writing to the database that whatever the modified value here. And that final write where it is taken, it is in the transaction T2. Even in S2, it is taken in the transaction T2. That's what here we have a initial read and update read as well as final write. In both the transactions, it will be having same. That's what these are called as a view serializable schedule. So in this, we can notice it is not a view serializable schedule because initial read it is here T1 and here also we have a T1 itself. But here we have a update read it is not there. Here it is not there and even here it is not there. And final write it is taken in the T1 here and it is in the T2. So these two schedules are not a view serializable schedules. These are the conditions for the view serializability. So then here we have a view serializability example. This is one of the typical example in which we have a initial value of the database as well as final update that it will be taken with a certain operations. Then if you notice the confliction between these transactions, read write it will be having the confliction from T1 to T2 and write it T2 to T1. Here only the cycle formation it will comes. So here we have a cycle formation in the precedence graph. So it is a non-conflict serializable, but still it is giving the accurate output. How it is giving accurate output means here we have a swapping between these two. In case of the view serializability, little bit leniency it will be given. We can go for the swapping between the two write operation. That is the exceptional case here. It is also right and it is also right on the same database. But whereas in case of the uh, conflict serializable, it is very strict. Here both are having the confliction. We cannot go for the swapping, but here we can do it. That WA and WA that it will be shifted. And now what happened? It is in the view serializable. Just we have to go for the values. Even initial value 100 and final updated value it is 0. Here also we have a initial value 100 and final updated value it is 0. That's what now this S is equals to S dash. That is, this is the non-serializable schedule is equals to view serializability. So now it is a view serializable. In this, there is no cycle formation at all when we'll go for this swapping and all. But the value updation, it will be same. So both are giving the same output here. That's what it is a consistent. This, it is called as a view serializability. And like that only here we have a non-serializable schedule. That non-serializable schedule means here in this we have a two types, recoverable as well as non-recoverable. When it is a non-serializable means it is not giving the output, proper output at all. Then we have to go for the rollback. We have to do undo. So whether it is possible to go for the previous consistent position or not. Based on that, we can say it is a recoverable as well as non-recoverable. So now here we have a non-recoverable schedule. Just we have to notice in this we have a read A that initial value of the database it is 100. It will be reading 100 minus 50. Then write A. Here we have a 50. What is the value it will be reading from T1 means that is a 50. Now 50 it will be reading here and that 50 plus 150 it will be writing 200. Now it is a 200 and it will commit. Means now it has been written to the database. Now database value 100 is replaced with the 200. Unfortunately, before committing the first transaction, here we have a failure, it will be occurring. Means roll back. It has to roll back to the initial position. So after by performing all these operations, now it will be roll back into the initial operation. Initial position means again the value of A it will be 100 here. That value of the A it will be 100. Now database value only it will takes. But already here another transaction, it has read some modified value from the T1 and it is committed. Already it has been returned to the database. It cannot be cancelled. It cannot be undone. So it is a non-recoverable. We cannot go for the rollback even though by doing rollback it is a inconsistent. Now when it is a rollback, value of the A it will be 100. 100 plus 150, it has to take 250. But now here it is taken partially executed value and that already it has been committed. So even though by rollbacking this one, it is not possible to change. This property, it is called as a non-recoverable schedule here. And then here we have a recoverable schedule. Only one slight change we have to do. Here it is committed before committing the previous transaction. From where it is reading the value, before committing that transaction, that recent transaction which it will be reading, it is committed. That's what the problem. Suppose now here we have a commit operation. It is after that of the transaction T1, then it will be recoverable. That property only it is shown here. So here we have a T1, it will be modifying the value, and then here it will be going for the commit. It will be going for the commit. After commit only, the next transaction it will be committing. Suppose here it is rollbacked. The transaction it is failed. In that case, what happens? Now it will be rollbacking. Rollbacking, and one more transaction, it will be reading the partial value, that updated value from the T1, but still it is not committed. So this also it will be cancelled. It will be cancelled, and again the database value it will remain the 100. Still it is not returned to the database. That's what, there is no problem at all. Once again it can go to the initial consistent position here. That again it will be taking the consistent value. This it is called as a recoverable schedule. So in order to get the recoverability, only the condition is that transaction which it will be reading the value from another return transaction value, that it has to wait to commit until to commit that previous transaction. Now reading value from T1 to T2, T2 has to wait until to commit T1 here. Then it will be recoverable. Then here we have a recoverable schedule. In that we have a three types, that is the cascading, cascadeless, and strict. So cascade means multiple operations in consecutively, that in subsequent steps it will be taking here. Now here we have a read A, that A it will be reading 100 minus 50, 50. So 50, still it is not committed, that it will be writing A equals to 50, and that 50 it will be read by T2, T3 as well as T4. All these transactions, they will be reading the value or updated value from the T1. So here T1 before committing, it will go for just before committing, it will go for the rollback. So when it will be going rollback, it has to cancel all the operations related to that one. That here each and every transaction, it will be rollbacking to the initial position. So one, it is rollback means all will be rollbacking. This is called as a cascade schedule. This is cascading schedule. In cascade, it will be canceling all the operations. And here we have a cascadeless. Cascadeless means just this after commit only, we have to read the remaining transactions. The remaining transaction should be reading after committing the first transaction. After updating, it has to commit, and then it has to go for read. In that case, after committing, there is no rollback possibility. And one more thing here, before committing itself, it is rollbacked means that all these transactions were not reading the data. No any problem with respect to this one. That is called as a cascadeless. Look here. Now here it is a commit. After committing, it is reading T2, T3 as well as T4. That's what here, there is no rollback at all. If it is rollbacked here itself, it will goes to the initial position, but still these transactions were not reading the data value. This is the cascade less here. And one more, we have a strict. Strict schedule, what it will be indicating, that always when it will goes to another transaction, previous transaction should be committed. T1 is committed, then only it will goes to T2. T2 is committed, then only it will goes to T3. Like that, any of the transaction, Tn it is completed its execution, then after committing only, the control is allowed for another transaction to continue here. That it is called as a strict schedule. These are the different types of the schedules classification. Serial, non-serial, serializable, and non-serializable. Serializable, in that we have a, in order to find out whether it is a conflict serializable or not, we have a precedence graph and view serializable. View serializable when there is a cycle formation in the graph, then it will be giving accurate or inaccurate. To predict that one, whether it is accurate or inaccurate with the cycle, we are going for the view serializability. And non-serializable, in that we have a recoverable as well as non-recoverable. And further classification in the recoverable. Yeah. So these are the different classification regarding the schedule. I hope it is clear to you.